That could just stay in there. Probably just going to snap the screw if I try and force it. Alright, now all this stuff can go in the parts washer. It is just another example of how bad that grease is. This is the neutral safety switch, the interlock switch. This is what keeps you from being able to crank the engine if it's in gear. And this thing is just encased in this disgusting, what used to be grease, that has turned into this gummy residue that everything appears to have stuck to over the years. Hey everybody, welcome back to another episode of the Tower of Power. I've got all the components here cleaned up, and I've got in my replacement parts, so I'm ready for reassembly. Last episode I talked about my problems with this key switch, how expensive the original replacement is because it is no longer available, and the people who do still have them in stock are asking excess of $50 for one. And I talked about the possibility of another solution out there, and that solution is from Sierra Marine Engine and Drive Parts, and it is part number M as in Michael, P as in Papa, 41000. I bought this switch at my local, well, fairly local marine parts dealership, and it was about 25 bucks. And that's about the same as what it would cost if I had ordered it online from any number of vendors, Amazon and such. So the great thing about being able to go there and buy it for the same price is not only was I able to get it for the same price, but I was also able to bring these parts with me and check and see how the fit was going to be. Because my main concern was, because this switch is an integral on-off start switch and also a push to choke switch. If I push in on the key, it actually closes a set of contacts in here and does the job of the Mercury 29759 rubber push button switch that sits in the top here. So if I had realized that I was going to need to replace this switch and was going to replace it with this switch, I could have foregone ordering this switch, which cost me, cheapest price I found was on eBay, cost me about 20 bucks for this switch. So I could have saved myself 20 bucks. I'm still going to install this switch because it does a very important job. It actually will fit right in here and close up this hole. So I would have to make something, a rubber disc or something, or plastic to go in here to close this hole up, because I don't want bees to go in there, or insects, or water, or anything to get down inside here. And as long as I'm going to install it anyways, I'm probably going to wire it in too. I'll just put it in parallel across the contacts that I'm going to wire the choke to on this switch, the new one. That way, I can either use the key to push the choke, or I could use the button on the top, depending on what I feel like doing. So, now that I've got all the parts and I know... Oh, so what I was saying was the reason why I needed to go see this switch in person to be sure was I hated the idea of ordering this switch online and knowing that it's a push-to-choke switch, that it's physically deeper, but I couldn't tell how much deeper, and it actually isn't much deeper at all. And the reality is, it's still going to fit. So my concern was this part of the metal casting right here. The rotating parts are right behind it, so I can't remove this casting. So this goes in here like this, right? And you can see it's kind of a tight space in there for the wires and everything to turn as it is. Turns out, when we put this switch in, we're going to have about the same amount of space because this sits out further forward. So the only problem that I see with this replacement switch over this switch is the original switch has a flat on one side and a flat on the other side that actually makes this skinnier at this point right here. And it's what basically locks this switch in, so the switch can't turn. If you're turning the key and this nut were to loosen, it can't rotate and rip the wires or short the wires against each other. Well, the new switch only has a flat on one side. So consequently, it will not fit in this hole. So there's two ways I could go about dealing with this. One of the things I could do is I could just grind out part of the metal here and just leave a flat on one side, okay? Or I could just file a flat on this plastic on this side. So I haven't decided yet what I'm going to do. The easier thing would be to file the flat on the plastic, I think. Clearly. My concern is damaging the threads. But I think I could probably clean those up with a thread file. So one of the other things I have to contend with is the wiring in the boat and the wiring harness for the engine, the condition that that's in. Those of you who've been following the channel probably recall that that was in pretty bad shape, and I was able to salvage a short length of it at the motor end, and then that transitions into the wiring on the boat, runs up the side underneath and comes out, and then some of it runs up to the dash. I'm mainly concerned right now not so much with the boat wiring, more with the engine and the control wiring here. So the wiring that was coming out of this was a total disaster, all dry rotted and corroded. So I'm probably going to have to replace a good part of the wiring from the control pretty far back. I don't know how far yet. So what I'm thinking I want to do is I want to have a way that I can unplug this control up here at this end. So if I need to take, for some reason, take this out of the boat, I can. And also because I don't really have a whole bunch of wiring that's going to be long enough to reach all the way back there. And I don't know what I'm going to end up doing as far as transition at the other end goes. I might end up just using regular double female crimp type splices and heat shrinking those. I haven't decided yet, but it wouldn't hurt to have something up here. So what I came up with for an idea is I have some of these plugs that I saved over the years. These came out of hot tub controllers. And the majority of hot tub controllers use what they call amp plugs, which are these plastic type of plugs that are not really weather tight because usually the control boxes don't have to worry about getting wet under normal circumstances when they're underneath the cabinet in a hot tub. But some manufacturers chose to use this style plug, which is called a J&J plug. And then there's another version which is called a mini J&J. A mini J&J is about half the width of this, so you only have about that much thickness to it. And those tend to be used for things like motors, blowers, and things like that that hook up to those hot tub control boxes. This is a full-size J&J plug. This was designed to actually hook up a topside control for the temperature and digital readout. So it's actually got these stouter pins and there's 6 of them. So I had one of these cords, okay, which is great. And then I had only one plug that I just salvaged out of a box. It's the last one of these that I have that fits this. So I could have used a mini J&J, but I don't have any that have enough conductors. So like I think the largest one I have is like a 4-conductor, 4-pin. And the problem is there are 7 wires coming out of the Mercontrol. One of those wires this salmon colored wire, it actually goes over, and when it gets over to the plug here, it doesn't exist over here because this is not a magneto ignition. So that wire is not needed. All that wire does is, that wire is shorted to ground when you turn the switch off to kill the ignition. In this particular setup, we don't need it, so I can omit that. So I really only need 6 wires. So for me to do it with mini J&Js, I'd have to have 2 plugs. By using this, I'm going to be able to get away with 1 plug, hopefully. The problem is I only had this 1 receptacle left in a box because most of the boxes that I saved have amp plugs in them. And unfortunately, at some point when I was stripping out probably the PC board or something, I probably didn't do this on purpose, but cut this ground wire. This wire would have gone over to the to a lug right on, bolted right to the box to ground it. So for that reason, I only have 5 conductors here. So I've got to try and salvage this if I'm going to get away with doing this all with 1 plug. Oh, this is what a mini J&J plug looks like. So you can see the difference in the size. Well, I managed to strip back the wire right to the base here, and I'm using one of these little brass ferrules to solder the 2 wires together. So that'll be a good electrical connection. Mechanically, it should be fairly decent. I'm going to bind all of these wires together. So I also put a piece of heat shrink tubing on the wire right next to it because as I was heating this up, it was almost impossible not to melt the insulation a little bit. So just for good measure, I put a little piece of heat shrink tubing on that, and now I've got a piece of heat shrink tubing I'm going to run down all the way onto this. The neutral safety switch cleaned up really well, and I checked it for continuity and it works, so that's good news. I desoldered the bad wiring that was on there, so I'm going to be able to reuse this. This gets installed right here. The problem is that when this is in, the cable is actually going to go behind it. This cable is going to go behind it, which is the shift cable. So what I want to do is I want to actually install part of the mechanicals with the shift cable. Then I can put this in. The other thing I realized is that now I was worried about damaging these threads, and it occurred to me that I don't really have to worry about that because I only need to file a flat on this little area right back here close to the edge for this to fit. It almost fits now, but rather than force it, I'm going to file that. Well, this nut's not going to fit in there because of that same problem, so I'm just going to have it tilted a little bit like that. Should be okay. So it's interesting, there's a little bit of a radius right here that kind of interferes with the body of the switch, right, this part right here. It looks like I could deal with that one of 2 ways. I could either, looks like I might be able to live with just having the switch tilted a little bit down, or I could file that flat a little bit more so that I can actually move the switch rearward a little bit further, and I would just have to put a washer or a spacer on the back. Actually, it looks like it. There's a brass washer that would probably go on the inside here and could act as that spacer. So I think that's what I'll do. Alright, so I went and got a couple of stainless steel cotter pins for locking these little pins in. I saw a reference on one website on a forum where somebody said that they used safety wire, which is a type of wire that you can get for tying off through types of fasteners that have holes like this. Even if I could find locally safety wire that's stainless, I probably would have to buy a whole roll of it, which I wasn't too crazy about. So I just went with stainless steel cotter pins. I think what was in here when I took this apart was either stainless or brass cotter pins. So this should be fine. So next thing I got to do is I'm going to install this in here. And before this goes on to this post, this plastic bushing goes on. And it goes on with the flange side facing down. So I'm going to put some lithium grease on here. And then on this surface, I'm going to basically grease this up really well at the pivot point. So I'm moving right along with the wiring here. Some of these wires, like to the switch here, I'm going to solder on just like they were originally. They were solder connections. On my original switch, all of the connections were soldered, but the new switch comes with these lugs that actually have threaded holes in them, and they give you these little brass screws to use. So on these, I've decided to use these eye terminals that are crimped on, and the reason why I did that is because I saw a warning by somebody online who said that this switch does not tolerate much heat, that he had attempted to solder onto these connections right here by sticking the wire through the hole and soldering, and that he ended up ruining a switch and had to buy a new switch. Now, it's quite possible he was using way too much heat. I don't know, but I figured rather than run the risk of that happening, I'd just do it this way. So a couple of these wires, the eyelets, the little crimp-on connectors actually have two wires going to them. And, you know, oftentimes when you put the two conductors together, they'll still fit within the metal part of the crimp connector, but they won't always fit in the plastic part of the sheathing. And what I found you can do is, if you take some, like these are perfect, these are like almost like duckbill style pliers, you can crush down just the plastic end without crimping the metal, and take that round end and kind of flatten it into a wider oval, and the two wires will fit side by side. You can actually see these two wires right here fit in there perfectly, so that way the insulation's actually into the connector like it's supposed to be. And then I crimp them on. So the reason why a couple of these have two wires is because, for instance, the this white wire here, this is the 12 volt when the ignition is on. So this terminal, which I haven't hooked up yet, is going to be where the 12 volts comes in from the battery. And when the key is off, there's no voltage present on any of these connections. When the key is turned on, 12 volts will be present on this white wire here, and it will be sent out through the wiring harness back to the switch box, which is the name that Mercury gives for the electronic ignition system, to energize the ignition system. Also, that 12 volts is going to go up here to one side of my choke switch. It also internally goes to one side of the internal choke switch. Then this orange wire is going to be my choke wire. So I have that attached to a terminal right in the center marked C for choke. So what will happen is, if the ignition is in the on position and you push in on the key, 12 volts will be present on that connection, will go out through here and energize the choke solenoid. But I also added a second wire that I'm going to run up to the other side of my choke switch, so that regardless of whether or not I choose to push the button on the top or push in the key, it will have the same effect. It will close the circuit and energize the choke solenoid. This is the starter solenoid. So the starter solenoid, we only have one connection off of the switch marked S for solenoid. The connection on this switch marked S for solenoid. That goes right to this side of the neutral safety switch. When the boat is in neutral, the 12 volts is allowed to pass through the switch, go down this yellow wire, and when the switch is moved to the crank position, the 12 volts will go to the solenoid. If the boat is not in neutral, this switch will not allow the 12 volts to go to the motor to the starter solenoid, and therefore the starter will not rotate accidentally. So now I'm just going to solder on a few of these connections here, and it's really tight quarters here, but it can be done. It takes a little bit of patience. I taped up this my homemade wiring harness here. I taped it up, and then I wrapped some scrap rubber material from old bicycle tubing around this area here so that I could get the original strain relief to grip this and give me some protection as far as this getting, if this accidentally gets pulled on. But once it's in the boat, there's really no reason that should happen. But I don't want it supported by strictly just the wires attached to the switches. And the idea is we don't want to overheat that connection. And this is what makes this such an adventure. You got to make sure that all of these wires are out of the way of the mechanics that are going to be on this side of this little partition right here. And it's a pretty tight fit, especially when you're using those spade connectors like that. But I managed to get it all in there. Also, you may have noticed that I've repositioned the choke switch because I had it in the wrong slot. Turns out this slot up here is not where this is supposed to sit. And I found that out when I went to put this chrome trim ring on. There was no way to have this up high because this would interfere with it. So this is how this is supposed to go. When I originally took the thing apart, this fell out of somewhere and I don't remember where it went. I tried putting it in here and it just caused problems, so I'm going to leave it out. I think it may have been a spacer from the original ignition switch over here, so I think it's going to be okay to leave that out. The diameter is nowhere near any of these moving parts in here, so I know it had something to do with over here. So also I had to make sure the wires were out of the way of the neutral safety switch. So I think right now this should be able to close up and should be okay. This wire right here, I'm just going to cap it off. There are 3 wires that are not, well, technically there's 2 wires I'm not using. This black wire is a ground wire that I would run to one of the magneto terminals on the switch if I was using this ignition switch with a magneto ignition outboard. But since I'm not, I don't need to do that. There should be an additional white wire, a 3rd white wire coming off of the switch to feed 12 volts over to this port way over here for the tachometer. But I don't even know if my tachometer is present and works on the same, if the tachometer in the boat would work with my motor or whatever. So I'm going to worry about that later. I'm going to keep the wire in here. I'll keep it long enough. I'll probably just terminate it over here somewhere so it's out of the way. This wire was already short, so I'll just cap it off and leave it inside here. And this would be the wire that would make up the brown wire that would send the pulse to the tachometer. So I'm just going to cap that off and not use it for now. And then, like I said, I'm not going to run the white wire with the 12 volts over here because I'm not even going to probably use this port. Alright, I've rearranged my wiring. Looks pretty good. And I just did a dry test run to make sure that the cover is going to go on. It's pushing back a little bit here, but that's actually this rubber part on this choke switch. So that's actually normal. So I think we're all set to complete the mechanical reassembly here. So I'm going to install the warm-up lever. There's these 2 little almost like wavy washers. Go in here. And then this little metal retainer plate and 3 screws. Now I've got to put this plastic bushing in and put a little bit of lithium grease on this area here. So this side with this part right here sticking up has to face down. That's neutral right there. I guess I can put these two little metal keeper things in. And because I lost that little roller that goes in there, I had to order a new one. So I'm just going to take a moment to grab that envelope. All right. There's the new roller. And all that does is it clicks into these detents and basically gives you a positive, you know, positive lock into neutral.
I don't know. If you want to come down, that'd be cool. Control, I have a name ready.
Alright, now I can install this new cable I picked up off of eBay. This is a Teleflex, Teleflex CCX 17915, and this is the heavier duty version of the cables. I think I'd mentioned before that the shift and throttle cables are identical, but there are two different versions available. So this is what the heavy duty version looks like. This jacket appears to be thicker. Yeah, so I'll show you when I put it all together. You'll see them side by side. You can see the difference. Quality seems like it's pretty decent. So all right, let me get this hooked up here. This is gonna have to go in here like this. And get my other stainless steel cotter pin in. Alright, it occurred to me that in order to facilitate being able to put this back together easier, because this part right here has to go into the slot at this point, because once it gets over to here, it actually rides in a track. This plastic bushing is going to be in the way if I keep it on this side, so I am going to just swap it over to this side, and there's enough grease on there it'll pretty much stick in there and hopefully not fall out while I try and do this. So when it's in neutral, this area right here that doesn't have the track is lined up with that. So if I manually rotate this all the way, well, let's see. What do I want? I want it. There we go. Alright, so it should do it. I'm just going to flip this over. There we go. I just moved that until it dropped in. The other thing I did is I loosened up this nut on the new ignition switch so that that wouldn't be in the way. I could tighten this up after I get it all clamped together. Just flip it over on this side, temporarily install the handle. Why doesn't this sit right there lined up with neutral? Well, let me put a couple of screws in this. I know these two top screws are short screws that just have nuts on the back side. They don't go into the boat, whereas some of these screws do. I don't remember this doing this before, where the whole cable would tilt down like that. I mean, it is moving in and out at the other end like it should. No, looks like it is working correctly because I've got the cables in a vise down the other end of the bench there because I don't want to kink the cables too badly or whatever. And while watching the cables down there and seeing how they're responding as I shift, it seems to work pretty well. See, when I push it forward, the throttle cable doesn't move at all. Just the shifting cable moves until about there. At that point, the throttle cable starts to, well, actually about this point here, the throttle cable starts to move. Alright, I just tightened up this nut. This trim ring, which I would like to have reinstalled, unfortunately, it has a different thread pitch on it. It's much finer than the threads on this new switch, so it does come with this plastic one, so I'll just end up using this. Alright, so all I have left to do now is going to do some out of the boat electrical testing with my meter to make sure everything is hunky-dory with my switches. Alright guys, so I plugged in my cable into my makeshift plug here. And the other end of the cable, I just stripped the wires. I'm not going to bother with green and black because I know that I end up not using those for now. And I'm only concerned with red, white, orange, and yellow. So I switched meters. This meter has a continuity checker that is audible. So that's going to make my life a little bit easier. So I'm going to hook up an alligator clip, and I'm going to hook up one lead of the meter to the red wire, which would be the wire coming from the battery. So that's the wire that the 12 volts goes in and feeds the whole system. So right now I should have no continuity between any of these other wires. Okay. So far so good. Now, put the key in, turn the ignition switch on. I should now have continuity between red and white. And I do. So now 12 volts would be going through the switch along this white wire back to the ignition system on the motor. At this point, I should also still have no voltage on either one of these two connections. I already forgot which one I ended up using for choke. Let's see, is it orange? Yes. So the orange wire is the choke wire. So with the ignition switch on, if I press the choke button, and also if I press the switch in, so both switches will work for choke now. If the ignition switch is off, there is no choke action because that 12 volts for the choke comes from the 12 volts coming out of the switch, not the battery going in. So last check, the yellow wire is the starter solenoid. So when I turn the switch to the crank position, I should get continuity. And I do. And one more check. I want to make sure that this continuity stays when I turn this switch. And it does. Because if it went away, what would happen is that would mean that while the engine was cranking, there would be no spark. And then as soon as you stopped cranking, spark would return. And I forgot exactly how, but there's a way you can miswire it where it will actually do that. So anyways, good to go. So next time you see this thing, hopefully it will be in the boat.